Amale.
In this project, we are going to analyze and apply our previous knowledge in differential and integral calculus to solve application problems that involve both subjects. To solve our problem, we need to know what implicit differentiation is, which is a method which involves differentiating both sides of the equation with respect to x and then solving the result for y. We also need to know why are related rates of change an example of this type of differentiation. And since in related rates of change problems we have to establish a relationship between the factors, the best option is to use implicit differentiation to establish and to arrive to the relationship of these factors.
Number 5, and our problem consists in water is leaking out of an inverted conical tank at a rate of 2,310 cubic feet per hour. The tank has a height of 12 feet and the diameter of the top is 5 feet. Calculate the rate of change of the height of the conical tank when the height is 3 feet. Now, in our sketch of the data, we can infer that the conical radius is 2.5, which is something we will need in the procedures.
In this project, we use the data they gave us. We use similar triangles, which are 2.5 feet over 12 feet. We use volume formula in order to solve the problem. We substitute values with the volume formula and then we derive the volume formula. Then we substitute with the height they gave us, which was 3 feet. We simplified and then solved. Use all the data. Use similar triangles. Use volume formula. Substitute when the height is 3 feet. Derive the equation. Substitute value to the formula. Solved for the result.
In this problem, we learn how real-life situations can be solved and measured using calculus equations. As an example, we can see that in medicine, cancer growth is measured using differential calculus to measure the rate of change in the patient's body. And in economics, that we can use differential calculus by studying and defining which invest option is the best using differential equations.